Okay. So I think we can slowly start. So hello, everybody. Thanks for joining us. I would like to welcome you to this webinar about fraud detection. Specifically, we'll focus on credit card fraud, but we'll talk about that more later. So let me start by introducing us. This webinar will be led by Esther. You may know Esther from our other webinars or product launches or stuff like that. But let me introduce you anyway. So Esther Bergmark is our Director of Product at Graphware, and she is in charge of Hume. And with her more than 10 years of experience, she is doing a great job leading the growth of our product line. So welcome, Esther.
Thank you.
And my name is Alexandra. I'm part of the marketing team, and I'll say just a couple of words, so Esther doesn't have to speak the whole time. So let us jump to our agenda. We'll first introduce Hume, our product, and then we'll talk about fraud in general and payment card fraud detection specifically. Then we'll have a demo of what fraud investigation in Hume could look like. And of course, we'll wrap up with Q&A. So don't be shy, ask questions. Great. So let me start with a poll because we're curious. So I'll give you a second to answer that before we jump into stuff. Awesome. All right, great, thank you. So you can see the results. So, okay, let me start by introducing Hume. So as you know, Hume is our product, and it is a graph-powered fraud detection and insights engine sitting on top of Neo4j. This is why we often say that it's the missing link or connection between Neo4j and the end user. And that's very powerful because it lets you leverage and expose the full power of graphs, full power of your data to your analysts, data scientists, and investigators in a matter of days. So the key benefits we're talking here when it comes to fraud detection is reduced time to insight, meaning obviously that fraud can be detected faster, breaking down silos between teams, and thus letting people collaborate more easily, doing ETL seamlessly, so extracting, transforming, and loading data is very easy thanks to Hume. And finally, connecting all the data into one source of truth. We refer to this as well as the organization's second brain, where all of your data and all of your knowledge is connected and integrated in one place, which makes it very easy to work with. Okay, so that was a little bit general, but let's drill down a bit deeper into what can Hume do for you when we are talking specifically about fraud detection. So very easy, you can detect fraud and find fraudsters faster. And this is possible thanks to several things. For example, our lightning fast graph visualization. I think we've talked about the benefits of visualizing data in a graph before, but basically it's about making your analysis easier, being able to draw insights and conclusions more easily, more quickly, understanding connections and relationships between the data more easily, noticing patterns more easily. And all of this is possible and very fast because Hume brings this visualization to you thanks to fast rendering and short time to query very quickly. Next, we have the no code aspect of the solution, meaning you don't have to spend time on coding, but you can use our pre-canned cipher queries and very friendly user interface that lets you to do your analysis quickly and focus on what's important. You can also leverage role-based access controls, which gives you the extra layer of protection and safety around your data, as you can decide which role of user sees what and can do what with the data you have. And finally, as we said before, you can create a connected data set, meaning all data can be connected in one source of truth, and you can find connections among disconnected data sets easily and quickly.
And I think, Alexandra, this is the point where I take over, right? Thank you first.
Yes, thank you.
For your nice introduction. That was great. And I thought also the voting that we did was incredibly interesting. Thank you all for participating. That was really interesting results. You just mentioned the connected data set, right? And here is really where the features for fraud detection come on top, right? You build your connected data set in Hume or in the graph visualization tool that you have. And from there, you leverage your graph database. Hume enables efficient fraud detection in several ways. And I would like to name its highly powerful and responsive graph visualization first. Since this is the place where investigators work most, where they see patterns and detect fraudulent activity. Hume's visualization does not only come with many features that facilitate pattern recognition and data analysis, such as actions, styles, grouping. It is also extremely fast, and you just mentioned it, Alexandra. And the reason for that is that it's graph native. It's built on top of Neo4j. It's not just connected to it in some way. The visualization can be enriched with a temporal dimension, which allows to see fraudulent activity in its context and time, which is always very powerful when you analyze data. Similarly, data can be displayed in its geospatial context, so on a map, allowing for quick recognition of anomalies and patterns related to location. Datasets are often very large, and then they can't be analyzed in their full size. Hume offers several ways to prevent exploding networks, such as virtual relationships and previews. And you're going to see that later in the demo as well, how we work with a very, very large data set, but we only work with one aspect of it. Another way of achieving something like that, to achieve focus for the analysis, is to use perspectives in Hume. They are another way of enabling focus analysis, as I said, and they let you create a view on a data set, and by tailoring which types of data you want to show and which types of relationships you want to show in this perspective. Once analysis has been done, or in certain points of the analysis, findings have to be shared and discussed. Hume lets you take snapshots of the insight that you gained. You can comment them and share with others. They can also be saved as evidence and used at a later point. And then finally, alerts. They take the burden of the proactivity of analysts. So analysts don't always have to go in and search things in the whole data set. Instead, an alert monitors for changes and notifies the analyst in case action is needed. And you're also going to see that in our demo later. Now, fraud is a really big topic. It's a global problem that causes industries, institutions, and of course, individuals losses in the range of billions of US dollars every year. Fraud can be committed in many ways. We would simply run out of time today if you wanted to cover them all in today's webinar. The ones that are listed on this slide that you see now are the most prevalent in the digital world. And all of them are subject to investigations that can be conducted with inside engines. Though inside engines use cases aren't limited to those cases that you see here, or these use cases. Identity theft, difficult word to say, but it's also a method to use that often leaves deep scars for the victims, since personal data is used to an extent that encompasses the identity of the person, and the financial advantages gained on the cost of that person. Insurance fraud hits insurance providers hard and disadvantages those that suffer actual losses and are really entitled to compensation. Phishing, again, victimizes mainly private persons and leads not only to financial losses, but also to lower trust in communication technologies such as email and text messages and so on. Lastly, payment card fraud is a method that hits payment card providers and individual people almost equally hard. During payment card fraud, goods and services are obtained on the cost of the provider and the individual. While all these types of fraud and most others are best analyzed with graph technology, we would today like to use the example of payment card fraud, since it is a very widespread problem. Now, when it comes to the case of payment card fraud, most of you might know it, but just to set the stage a little bit from the start. Usually in some device where cards are physically swiped or entered, a device is installed that kind of copies the data on the card. Sometimes even with the camera, the PIN code when it comes to debit cards, but most often it's on the swiping device that the credit card information is copied. In 2019, payment card fraud led to $28.65 billion in losses worldwide. I thought it was an astonishing number. That's why I wanted to share it with you today. And according to a report by the European Union, these cases, over the years, the cases in payment card fraud have only been increasing. There was a short time in 2015 when they stayed level, and then they have been increasing. And apparently now, during the pandemic times, they have been even further increasing. Payment card providers are, of course, working diligently to detect fraud and contain damage through early detection. There are several methods that they can use. And those methods can roughly be categorized as statistical data analysis methods on the one hand and connected data analysis on the other hand. Just, there are lots of different statistical data analysis techniques. We list a few here. One of them is data matching, which is used to compare two sets of collected data and understand divergences and trends. There's the probability and distribution models that can help to understand where and which fraudulent activities are likely to happen. And then statistical parameter calculation that summarize or describe an aspect of a data set and can point out outliers. So with all that, you have the different data points and you can see and analyze them as the data that they are. Now, when it comes to connected data analysis, data is seen in the context of other data and events. So that's the whole thing with the graph. You have the data points and the connections between them. It is undoubtedly the best method or the best model of pattern detection. Often where individual transactions pass a statistical test, they can be detected as a suspect activity by deeper insight into nested relationships for patterns that are not readily discovered with other forms of analysis. So, when you see the relationships and relationships under certain relationships and so on, you get much deeper and better insights. Because the network of influencing agents and variables is modeled and analyzed in real time, and here we come back to speed. Insights beyond the capability of statistical models is simple for graphs. We say here that the real-time detection can come up with 1,000 times the speed of the analysis of relational databases. And that is true for those tools that are graph native, that sit on top of the graph database. Graph data can calculate the actual instantiated decision model, a network of influences to affect an outcome. It's also much richer in insight and relevances than a statistical model. And all these reasons make us believe that's the very best method to prevent fraud, detect fraud, and get insights that help institutions and individuals in the same way. Good. Now we talked a little bit about the background and the different methods. And from here, we would actually like to take you to Hume and show you how Hume solves the problem. So let me, bring you over to Hume. The demo we prepared exemplifies the case of credit card fraud. We will show you how a fraud investigator that is employed at a credit card institute can investigate a fraud case, detect the connected fraud activities, and initiate measures to stop them. Yeah. Okay. I stop my video now so you can fully focus on the demo. Okay. Good. So what you see here, let me close this so you see it in its full size, is first of all, we are in the visualization of Hume. You see here that there are different parts of the application, but we want to focus on one part of it today so that you get a good impression in the short time that we have in this webinar. Before we start the investigation, I want to show you the data model, the schema that our example credit card company uses. The company has modeled the data according to their domain, and that way customized Hume to their business case. The data is suggested to be visualized in Hume, and it comes from several sources. So from pretty much all the data sources that the credit card company have, the data can be ingested. Hume ecosystem makes it possible to create a unified view on all the data sources in one single domain-specific visualization. And that's very much what you see here now. Our investigation starts today with a note from my colleagues at the customer service center of the credit card provider. A customer has called to report an issue with a credit card. I have the credit card number here, and I will start out by searching for it. Now, it was what I know is that activity was reported that seems not to be okay. So I want to drill into that. And here's the credit card. So first of all, I would like to, before I expand any data, I want to make sure that I don't see too much data. So I adjust our timeline here to the year that is interesting to me. So in 2018, we have a time period in the beginning of the year here. Okay, here we go. So the next thing I would like to know is who's the card owner. Oops, so here we go. Emily Parker, okay, that's in alignment with the data that I got from the customer service center. I would also like to know what transactions have been seen and been classified as fraudulent. So if I go here, I can see all those transactions, and I can see in the time bar here that they are very much concentrated in a certain time frame. Interesting. It's probably this area that is most interesting to us. Okay, good. It's very interesting to see that most of these transactions have been in approximate or in a very short time from each other. But before I want to draw any conclusion, I want to see what the first transaction was. So here I can see the first fraudulent transaction. You see here, this is the amount of the transaction. It was a swipe transaction, which means that it was physically swiped through a machine. And then I have the date and the time of the event. So we have this amount here, and I see right away that there's exactly the same amount here as well. And it's pretty much half a day in between, which is a very short time for a booking and a transfer back. So I know that a lot of fraudsters do it that they, in the very first time they take, they use the card, they reimburse the money right away again, just to check if the card works and to not draw attention. They also often use higher amounts so they can see which frame of work, which allowance we could say they have, how much money they, or they can actually use. So this is quite interesting from the time aspect, but I would also like to see how all this looks in the geospatial aspect. Let me just zoom out a little bit. Okay, here I see right away that the card holder is in the US. And it's also what I saw from in the note from the customer service team. She actually called from the US and said that she is there physically as well. All the transactions have been done in Europe. And if we look a little bit closer, we see that it has been done in the Rome area. And what I find very interesting here is, you see that too, right? We have one transaction here at 15:55 and one at 15:54 on the same day. Now, we don't have to be experts in traffic and of Rome, which I heard is rather chaotic, to understand that this is physically impossible. The card could not have been used in this short time difference in those two locations. It's simply too far away. So that's another way for me to confirm this, that something is wrong here. Now the credit card has already been, since the customer called, the credit card is already blocked. Action has already been taken. What I would like to do now is that I would like to take a snapshot of this, just in case I need it later. It could be that I want to return to this, show it to somebody, or maybe I call it investigation, or maybe I need it as proof later in a court case or something like that. So I take a snapshot, note down what I found, and save it. Good, so now I have it for later. With this, my work today has just started, because I know now that there was, that there is a problem, and of course, somewhere this the credit card information has been taken. There has to be a skimming device somewhere, right? So I go again to the first fraudulent transaction, which was this one, and my thought is that if I find the transaction that happened before, I can probably understand where the skimming device is installed. So what I will do is that I go a little bit back in time, 5 days, I think should be okay. And there are two more, you saw flashing up, 2 more transactions. Now they flashed up and then disappeared because they're not covered by my time limit. And that is, I find that very nice, because let's say it was thousands of notes. I would know that they are there, but I can control myself which ones I include into my analysis here. And I actually only want that one. I don't want the other one as well, because I only want the last one before the fraudulent transaction started. So it is this one, which is interesting. It's 2 days before, the Rome transaction started. Very interesting. I'd like to see where that happened. So who received the transaction? It was a shop in Birmingham, Alabama. I'll have a look at the map. It's not in Rome. There are only these 9 transactions from before. It's over here. There we are. The place where the credit card holder is registered as a home address. And if we look a little closer, we can see that it's a shop just a few blocks away from the address. Good. So, of course, the shop and the transaction here are in the same location. What I would like to see now, there's not much for me as working in a credit card institute to do about this shop with a skimming device. But what is really important for me at this moment is to prevent further harm to be done. So I want to go back into this view where I can then go a little bit deeper into the data. And what I do now is something that is very hard to achieve if you're not in a graph. I want to know who else swiped their card in this shop and within a short time afterwards experienced fraudulent transactions. Yeah, so it's advanced analytics that I'm doing here. For that, I have a wonderful pre-canned action. It's the fraud multiple hop analysis. And expanding this, it goes through all the data that we have. You see everything could have been loaded, but it wasn't because I have a time filter on, which is very convenient. So now I go a little bit back in time and include the next data set only and not all the data sets. I see up here, I have another person that is has been victim to this specific shop. Here's the credit card holder of this credit card, and here are the transactions that happened after the card was swiped in that specific shop, and they show characteristics of fraudulent transactions. So if I now look at which one was the first transaction, I see that it is this one. It should be this one exactly. Here at 14:10 on the 24th of April, and $160 have been deducted, and right away, actually 5 minutes after, they have been reimbursed. Same pattern. Now I would like to see the others. Look here on that day, there were 3, all in relatively close time to each other, and here we have another 3 that were also relatively close in time to each other, especially those 2. How does that look on the map? I see that the person is not registered in Birmingham, the credit card holder. So zooming out, I find the person here registered in California. Well, can be that he or she paid in the shop. Anyway, all the fraudulent activities are actually registered here on Hawaii. Okay. And one of them was used extensively in just one location. Oh, sorry, the card has been used extensively in one location. Again, rather big difference in location with a rather low difference in time. It is, in this case, for example, it would be possible probably to get different 3 hours. But however that is, I already know enough to know or to actually take action. What I'm going to do now is that I leave a comment to this because I think I detected a problem here. So I will comment on this visualization. I leave the credit card number. That was a problem. I have found that here in the properties and edit, and then I take a snapshot that I can later share with my colleagues. There is a department that takes care of these cases when people have to be called up, and we do a check if they have used their credit card in this location or not, if they were the ones that were so fast in using it in between different locations and so on. So I take the snapshot and then I go to it and limit the time frame again. So my colleagues see it just in the time that is relevant for them. Here we go. Okay, very good. Okay, so here we go. And from here I share it. Okay. And I can send that to my colleagues who then log into Hume and can take it from there. Now, all this was quite reactive, right? I got a note from customer service and started investigation. Usually, I don't sit and wait for those things. Usually, I have, or what I also have besides this is an alert that is set up. You see I have actually two different ones, but this one is one that would also that also alerts me on similar happenings. So what happens in this alert is that a pattern is run, or sorry, a query is run against the database that looks for exactly those patterns. Is there a card that has been used in a very short time difference in several locations? Is there an amount of money that has been booked in the 1 minute and reimbursed in the next minute, and so on? And once that happens, this query runs every 30 seconds. I'm notified, and I can see the event in Hume here. Here I already processed one. Here is a new one. I see this transaction is new. I can take it from here and start the investigation from here. Yeah. Unfortunately, my day of work as an investigator has just started. I have to investigate much more around this shop in Birmingham. But I think for the demo's sake, we leave it at here, or at this. And I would hand over to Alexandra. I would give you the word again.
Thank you. That was very nice and clear. Thanks. So we have one question about whether we can link Hume to other services. So it's easier to, for example, block a credit card directly or in a faster way.
Yeah, so I think I briefly mentioned Hume ecosystem, and of course it can be used to connect to data, or to connect to data in order to bring data in. In the same way, of course, data can be exposed to other services, right? So depending on the business needs of each organization that uses Hume, those things can be set up.
Mm-hmm. And is it possible to assign a score to a shop or to a person saying this may be fishy, but I don't have enough evidence to act on it yet, but so your colleagues know? That's
a very good question. It's interesting. I think the probability is generally a very important property that should be, you have different ways of, you can measure it either automatically or you can assign it manually. And then, of course, you can also have an alert that notifies you if a probability goes up and so on. So I think it's a very good point using that in the fraud case as well.
All right. Yeah, that's it from the questions. So
I see the demo was that comprehensive that nobody has many questions now. That was nice.
Well, thank you very much for the demo, Esther. Thank you everybody for attending. If there are any other questions that pop up, feel free to contact us. We also have the info@graphware email you can use. And yeah, thanks for coming.
Thank you all for joining, and thank you, Alessandra.
Thank you. Bye-bye.
Bye.